All right, hello fellow YouTubians, Almanzo here again. Okay, so now I have to make a drill hole in the half-inch diameter nylon balls. This is a number 29 drill bit drilled to a depth of 450 thousandths ish. Um, and then it of course gets tapped for an 832 thread. Okay, so I have a bunch of these to do, but I don't want to go crazy coming up with some sort of fancy fixture. So improvise, adapt, overcome. Use what you've got. I bench engineered a very quick solution. You need to be able to hold these things pretty darn tightly while you're drilling them so they don't shift or start spinning. Because remember, we're going through nylon and we're not using any sort of cutting fluid or anything like that. So this thing's going to have a tendency to want to spin on you. Trust me, I've tried, several different methods, and yeah, you can't really clamp these things tight enough with your fingers. You don't want to use them in a vise because you'll put flats on it, so on, a lot of different reasons. So I came up with this. So please excuse the crudity of this video. So let me see here, and here we go. Here's what I come up with. Very simple, very easy. Okay, so I used my existing fixture. I simply side shifted a little bit, drilled potted hole, then milled in a 375 thousandths diameter hole to a depth of 250 thousandths or a quarter inch for those of us that live in America, and then put a 45-degree chamfer on here. Then the ball sits in there like that. Okay, so how do we hold it? Well, simple. Using my table and a stud and a parallel bar, I have adjusted this. So now, there, I have an extremely simple way of holding this down just by applying pressure here. Okay, I have this adjusted so that when I come down with my drill bit, okay, sorry, I'm in the way there. But when I come down with my drill bit, my dial indicator will hit 0. Right there. So, I go down to 450-ish, and I know that I'm exactly at my target depth-ish. I say ish because it's not super critical. Okay, so I'm drilling this, no cutting fluid or anything, because I don't want to, deteriorate the nylon itself by introducing some cutting fluid or whatever, and it's really unnecessary. I'm running at a speed of 1000 RPM. So, okay, so this is the way this goes. You take the nylon ball, you put it in here. You bring this up, you slide this over, you come down. And I turn the machine on. And I let it spin up, and I go down to 450. And I'm at 350. There we go, 450. Stop there, take that out, and voila. I have not marked the ball. I've not left any dimples or impressions on it. And the hole is perfectly centered. And I simply then drop that into the done bucket. Little bit of compressed air. Go back, grab another one, drop it in there, flip it up, over. Here we go. Start. There we go. Done again. Rinse and repeat. So, work smarter, not harder. Okay, and as a bit of a bonus here, we'll just, well, I don't know if it's so much of a bonus. Okay, so, this over here, bring my monitor with me. These are the parts that have all been drilled. They all need to be tapped. And those were the upper assemblies. These are the lower assemblies. And ooh, what is that? Yeah. So, let me just grab a hold of that and show you folks what all of this is about and what all of this is for. So, grab my monitor here so I can see what I'm doing. So I'm sure that you can see what is going on here. Again, please excuse the crudity of these videos. They suck, I know. You get what you pay for. Okay, so can I bring that down a little bit more? Yep, there we go. I guess that's okay. So yeah, this is what all the fuss is about. This is the bottom cup, which goes into the neck assembly, and this is the top one, which goes to the plate, which has the head on it. And this is what they're meant to do. Okay. And of course, when the Johnny 5 robot is fully articulating and these things are rocking and rolling, that's how they work. Okay, just like that. You can see these are very fluid. They move very easily. I'm still in frame. There's no, movement there. It's very precise. And yeah. Some of you may be 3D printing these things or have come up with something different. I strongly advise against it. Listen, this head is going to be rocking and rolling. There's a lot of a lot of people are like, oh, the head doesn't weigh that much. Well, yeah, it kind of does, and it's expensive. Expensive servos, expensive machine parts, 3D printed assemblies. Yeah, you have a lot of time and effort into these Johnny 5 heads, and the last thing you need is a part like this to fail and the head go crashing to the ground. Yeah, this is what it is. This is the reason these things have been designed and made out of aluminum, because they need to be tough, and failure is not an option. So unless you want your Johnny 5 head crashing to the ground and causing potentially thousands of dollars worth of damage, yeah, you need a set of these. It is what it is, folks. So, all right, yeah, so I'm going to continue my efforts and keep machining these things, doing this particular operation. The next one will be the tapping operation, and then just pretty much some wrap-up stuff, and I may do a video to show just how strong these things are. So, all right, that's about it, folks. Talk to you later. Almanzo saying bye for now.